Hi, this is Roji. In this video, we'll see an important problem in artificial intelligence called missionaries and cannibals. Okay, so as you can see in the figure, there are three missionaries and three cannibals who wish to cross a river, right? So they need a boat for it. They have a small boat that can carry only two people. Anybody can navigate the boat. But at any time, on either bank of the river, for example, we have a left bank and the right bank. At any bank of the river, the number of cannibals should not be greater than the number of missionaries because they will outnumber and they will eat the missionaries. Okay, so the state which is given here is Q is equal to M comma C comma B. M is the number of missionaries, C is the number of cannibals, and B is the boat, right? So we are assuming that initially all of them are on the left bank. So the initial state is 3 comma 3 comma 1 and the goal state should be 0 comma 0 comma 0. All of them should have crossed to the right side. Okay, so the left to right is shown by the left to right arrow and the right to left is shown by a right to left arrow. Okay, and the conditions are the boat can accommodate, as I said, only two people. At any point of time, number of cannibals should be less than the number of missionaries on either side of the boat. Okay. When a missionary crosses from left to right, you should subtract by 1 comma 0 comma 1. Okay, because if the first number stands for the number of missionaries, the second number stands for the number of cannibals, and the third one stands for the boat. Similarly, when a cannibal crosses left to right, we should subtract by 0 comma 1 comma 1 because the boat has gone from left to right. There is no boat in the left bank. A cannibal has also crossed from left to right. So now we'll form a chart for this so that we can understand it very clearly, right? So initially I can put the state as 3 comma 3 comma 3 3 or 3 3 1 0 0 0. So all of them are on the left side of the boat, right? I'll take the first case as one missionary and one cannibal are crossing from left to right. So what will be the resultant one? I should subtract 1 from 3, 1 from this 3, and the boat is also not there. So what will I get? In the left side, I'll have 2 2 0, and in the right side, I will have 1 1 1. This is a valid state because the number of cannibals has not outnumbered the number of missionaries. We'll take the next condition. 1 missionary and 0 cannibal crosses from right to left. Okay, now I want you to think for a minute here. In the previous state, I am saying that one missionary and one cannibal has crossed from left to right. What if I had taken one missionary and two cannibals from left to right? What will happen? In the right side, the number of cannibals will be more than the missionaries. So this is a state which has to be avoided. We are not showing the negative states here as far as possible. We are trying to show only the states which are possible. Okay. So the next is one missionary, zero cannibal from right to left. So when I go from right to left, what will happen? I should subtract one missionary from the right side and 0. So in the left side, I will be having 3, 2, 1 and 0, 1, 0. Okay, this is the next state. In this state, again, I'll take a case. I'll expand my page to the right. So please listen. In this state, we'll take the next condition as 0 missionary, 2 cannibal from left to right. So what will I get here? Now I think it will be clear for you. 3 minus 0 is 3. Okay. 2 minus 2 is 0. Right? And there is no boat. Okay. And in the right, what will you have? 0. Already there is a 1 here. 1 plus 2 is 3. 0, 3, 1. Okay. I should put arrows everywhere. Yeah. But that will be more easy. Yeah. Now, I'll take the next condition along with this. The next condition can be 0 missionary and 1 cannibal from left to right. Okay, 0 missionary and 1 cannibal from left to right means there are 3 missionaries in the left side. So that 3 will be maintained here. 1 cannibal goes to the right side. So 2 minus 1 is 1. And 1 boat is also not there. 0, 1, 0, colon. What will you have in the right side? The number of missionaries has not increased, so it will be 0. The number of cannibals has increased by 1, so 1 will become 2. And the number of boat is also more. Is that clear? Okay, this is the next case. Now, still I have not reached the goal state, so I should keep experimenting such that I am not violating the condition that the number of missionary is less than the number of cannibal. Okay, at any side of the bank, I want you to remember. I'll take the next condition. 0 missionary and 1 cannibal go from left to right. Okay. So already there are 3 missionaries here. That is not going to be affected. That will be maintained as such. One more cannibal has come here. 0, 3, 1, 1, colon. 0 was the content here. That is not changed. 1 cannibal has shifted here. 2. Boat is also not there in the right bank, so this will be the case. Okay, now we'll take the next condition. So we are avoiding all the possibilities which will cause the number of missionaries to be less than the number of cannibals. Okay, we'll take the next condition. 2 missionaries and 0 cannibal go from left to right. Okay, 2 missionaries and 0 cannibal go from left to right. What will happen? In my left side, I have 3 missionaries here. 2 missionaries have gone there. So the number of missionaries in the left bank will be 1. The number of cannibals in the left bank, it continues to be 1. There is no boat. Okay. And the number of missionaries has increased by 2. So this will become 2, 2 and 1. Right? Okay. We can take one more state. What is the next state? I can take 1 missionary and 1 cannibal from right to left. If you assume the cases which I have neglected, you will understand that I am taking only the cases which will avoid the danger mark. I am assuming 1 missionary and 1 cannibal go from left to right. So 1 missionary was already there in the left bank. It will increase to 2. Right? The number of cannibal is also increasing by 1. So it will become 2, 2, 1, colon, 1, 1, 0. Okay. Still I have not reached the goal state. So I should proceed even further. Right. What is the next state which I can take? I'll assume 2 missionaries and 0 cannibal goes from left to right. Right. So when 2 missionaries go, in the left side, what will happen? There were 2 missionaries there. That will become 0. So in the left bank, it will be 0, 2, 0, colon. There was already 1 missionary in the right bank. 1 plus 2 will become 3, 1, 1. Okay. So still we have not reached the goal state. Okay. So I'll take the next case. What's the next possibility which I can take? Okay, I'll see 0 missionary, 1 cannibal from right to left. Okay, so what will be the value now? I think it will be clear. I know I need not explain. 0, 3, 1, colon, 3, 0, 0. I have not reached the goal state and my condition is also not violated. So I'll try to take the next one. Right, 0 missionary, 1 can. I'll try to take the next one. 0 missionary, 2 cannibal, which will make it as 0, 0, 1, 0. Right, 0, 1, 0, colon, 3, 2, 1. Okay. Now I have 2 possibilities here. I've drawn the arrow because I don't want to waste my lecture time. It will be easy for you. Right? I'll experiment with 0 missionary, 1 cannibal from right to left. What will happen now? So 0, 2, 1, colon, 3, 1, 0. And another case, 1 missionary, 0 cannibal from in this direction. What will I get now? 1, 1, 1, 2, 2, 0. Still my condition is not done, but I think I am closer to what I need. So what can I do? In this side I have 2 cannibals. I can safely shift them to the right side. So I'll put 0 missionary, 2 cannibal to the right side, which will make my state as 0, 0, 0, colon 3, 3, 1, which is nothing but my goal state. Okay, one possibility is done. Now here I'll come to this path. Right, I'll come to this path. What do I have here? I am in 1, 1, 1, colon 2, 2, 0. Right, what can I do now? I can shift 1 missionary and 1 cannibal from left to right. This also will make me reach the goal state. Okay, I have reached the goal state now. I'll come to the other paths. In the other paths, yeah, I'll take this path here. I'll stop here. I'll take this path. Okay, in this, I will assume I'm taking 0 missionary, 2 cannibal from right to left. What will happen? It will be 3, 3, 1, colon 3, 3, 1, colon 0, 0, 0. But I say this is not the right state. Why? It is not the right state because it is equivalent to my goal state. Am I right? So what will happen next? It will form a loop. It will form a loop. So this path is not the right path. This path should be avoided. Am I right? I don't want it to be eternally circling between these loops, right? So I'll avoid that. Now I'll come to the paths which I have left out. What if I take 0 missionary and 2 cannibal here from left to right? What will I get here? I'll get 3 missionary, 1 cannibal, 0 boat in the left side, 0, 2, 1 in the right side. Right? Again, 0 missionary, 1 cannibal from right to left. What will I get here? Again, 3, 2, 1, colon 0, 1, 0. Okay, 3, 2, 1, colon 0, 1, 0. Again, this is also not the right path. But you can see here, when after I reach this path is similar to what? This path is similar to this path. Am I right? This branch. So beyond this, all the steps are going to be similar for me. So that path I need not explore again because it is already explored. Okay. I'll take one more condition. I'll take 0 missionary, 1 cannibal from left to right. What will it be now? It will be 3 missionary, 2 cannibal, 0 boat, 0, 1, 1. Right. Next I'll take 0 missionary, 1 cannibal from right to left, which will make my state as 3, 3, 1, colon 0, 0, 0. I say I should stop here. Why? Again, I have gone back to this path, right? Which is again a loop, right? So it is not a wanted state. I'll stop. Okay. So, sorry. In this, what do I want? I want to finish or I want to reach from the start state to the goal state. What was my start state? 3 missionary, 3 cannibal and 1 boat in the left side to 0 missionary, 0 cannibal and 0 boat in the goal state. Okay. So how many states have I taken for this? Right? How many states have I taken for this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Within 11 states I have completed within 11 action I have completed my work, right? And we have also tried to expand down. Yeah, I have tried to take all the possible steps, but all those steps are not shown because that will make my graph very cumbersome. So this is the action. So within 11 possible steps, I have made all the missionaries and all the cannibals to reach the right bank without the cannibals eating the missionary. So this is one basic problem which you would have done in your childhood days, but this is how a machine approaches this problem. So my sincere thanks to all.